I'm Andrew Zolli. I oversee Planet's global impact initiatives. That is to say, our work to use space to help life on Earth, and in particular, to use it to advance humanitarian, ecological, sustainable development, what we call geodata for development activities, essentially to ensure that this very powerful platform achieves its highest and best purpose. And we work with constellations of satellites, NGOs, large enterprises, all kinds of organizations to help them use this remote sensing technology to advance inclusive planetary stewardship. Now, just a very quick introduction. You know, the planet is in a period of radical transformation. If you look at the Earth, and this is just a picture of the cities, the rail system, the air system, and light at night, you can see the way in which human beings are radically terraforming this planet, not to mention, you know, with aspirations of living on others. In fact, actually, people who think about the ages of the planet actually have a term for it, this period we've entered right now, called the Anthropocene. This is a period that was dated recently to the 1950s, when human beings dropped the first hydrogen bombs on the planet. Millions of years from now, when future geographers and people who look at the stratigraphy of the rock go in and look at our history, they will be able to date this period exactly by the radioactive isotopes that are actually found in the rock that date from the advent of the nuclear age. Now, the challenge for all of us in our day-to-day life is that this kind of big, global, abstract change is actually really hard to see. It's hard to viscerally connect with it. But what we're doing on Earth is this. We're doing this, we're cutting down the forests at scale, and we're transforming those forests into cities. So if you want to understand what our ecological impact is at scale on the planet, it basically looks like this, back and forth. Now, the challenge for the Anthropocene is that this scale of change, and we're living in it, we're soaking in it right now, is so large, in fact, that it's hard to viscerally connect with. A wonderful environmental thinker named Timothy Morton actually said the problem of the Anthropocene, the problem of climate, is that it presents us with hyper objects that are so big, systems that are so large, that are changing in ways that are not the ones in which we naturally attend, that they actually challenge our very notion of what a system is. They challenge our notion of what an object is. They're larger than the normal dimensions of human life. And if you are not sensitized to change, it's very hard to address it because you can't fix what you can't see. So Planet's mission in this regard is very straightforward. Our goal is to image the entire terrestrial surface of the Earth every day in high resolution and make change on the whole planet, those big structural changes, visible, accessible, and actionable for enterprises, for communities, for institutions, for everyone, to create a participatory wave in how we steward the planet. Because the only way we're going to find our way to the next point of equilibrium, a sustainable equilibrium, is by working together. Now, you note there that actually it says mission 1, and we don't mean this in the mission 1 is quality sense. We actually mean it in literally our first mission is to image the whole Earth every day. We're actually working also on mission 2 and mission 3 and mission 4, a whole suite of missions behind them. But let me talk about how we're achieving this one. What we're doing is deploying, in fact, we've now just deployed the largest constellation of Earth-observing satellites in history, each one of them about the size of a bread box. Now, what that does is it takes technologies that used to be the size of a school bus and shrinks them by several orders of magnitude. It makes them simpler, it makes them more efficient, it makes them vastly cheaper, and as a consequence allows us to do missions that could never be conceived of before. Satellites are typically big, rare, and expensive to operate, and as a consequence, most of us don't have any access to them. But these constellations of microsatellites, which we call doves, and you can see they're actually covered in art here. We have a really thriving artist in residence program where we put artists cheek by jowl with our engineers, and they design artwork that is laser etched on all the satellites and sent into space. And what we're doing with them is we're putting them in a specialized orbit called a sun synchronous orbit. This is an orbit that, if you can imagine, what's your name? Nancy. So Nancy's the sun, here's the Earth, okay? Goes around on an annual basis, you all remember like kindergarten, spins on a daily basis, and is on a slight tilt. So this is a group of satellites that spin like this between the sun and the Earth, and as the Earth turns sideways underneath them, they collectively image the entire surface of the planet. Then we download all of that data to 30 locations around the world, 30 ground stations. We rectify and integrate that data, upload it to the cloud, and make it universally available. So this is truly big data. What we're talking about here are images of the Earth that collectively, when stitched together, are trillions of pixels a day. It's the whole Earth today and yesterday and the day before and the day after that. And as you can see, as we increase the scale size of the amount of Earth that we're imaging, the volume of data grows really dramatically. And it's amazing what you can see. So for example, in California, for a long time, for the last 5 years or so, we've had a very, very severe drought. I think everybody here probably knows that. And recently that drought came to an end. And across the Carrizo Plain in California, the wildflowers blossomed, and we can literally see the wildflower blossoming from space. You can see all kinds of amazing things from space. The Earth is beautiful. It's magical. It's sometimes indifferent. It's sometimes terrifying. And it's especially powerful when we understand the way in which we're changing it. And I'll give you an example of that. So here is a form of change. Just like that first image I was showing you is a picture of deforestation, in this case in Bolivia. What you're looking at, if you just look at the dates, you can see from July to August to September. These are hundreds of hectares of pristine forest being cut down. So we have the ability now to monitor every tree crown on Earth. And I want to say, just for those of you who might be nervous about this technology, these are pixels that are roughly 3 meters in size. So if you can imagine kind of like from where I am to one end of the stage squared. So we're not reading your newspaper, we're not even identifying what kind of car you drive. This mission parameters were picked so that they wouldn't violate that kind of privacy, but that they would reveal the kind of planetary change that's necessary to drive greater stewardship. Now, when you measure that kind of change on a regular basis, you can do something really powerful. You can combine it with advanced analytics and other data sources to tell you things about the planet you didn't know before. So here's that exact example. You can see it happening in the middle of the screen of deforestation. And what we're doing with an algorithm here is we're calculating the net carbon loss to the forest from each progressive act of deforestation. Now, when you measure something like deforestation and then you cross-correlate it with the total volume of carbon that's lost, you can begin to build a structure that lets you value carbon, to put a price on carbon. That's because this is the technology that's required to build the robust indicator that tells us about forest carbon loss or gain. You can do this with all kinds of things on Earth. This is an example where we're looking at supply chains and counting ships and ports. We have a very good sense, if you can imagine how much work has gone into creating sustainable supply chains. Think about how many organizations have promised the world that they will behave a certain way. Well, what we're creating is a transparent and inspectable planet. We can literally watch refugee camps blossom around the world and train algorithms to identify the visual signature of refugee camps so that we can find them in places that you wouldn't imagine. Now, we're very careful about the release of this kind of data, which we work very closely with a range of humanitarian relief organizations to vet and ensure that this data has the beneficial impact but doesn't have any downside risk. So I just want to be very clear with everybody that we're very careful about the way in which we use these technologies. And I'll just give you a sense of what's coming. This is a work that was done with our data set and a partner organization called Descartes Labs, which is a machine learning and computer vision organization using all of our data in China. So what you're looking at here is what is coming next, which is a visual search engine for the planet. Let me run you through that one more time. Let's see if I can do this backwards, okay? So what we're gonna do is we're gonna find one solar array, one large-scale industrial solar array in the deserts of China, right? And then we're going to look and find self-similarity, find all of the others located around the country. Now, if you can imagine being able to say, we've identified an act of deforestation, we've identified an act of climate migration, fill in the noun, and now let's be able to look around the world and really produce, for the first time, a robust and real-time indicator for how that is unfolding on the Earth. But it's not just about seeing what's going on today. It's also increasingly about understanding what's coming tomorrow. Historically, when you don't have a lot of imagery about what's happening on the Earth, when you get it, it largely allows you to see what's happened in the past. As we move to real-time, persistent, remote monitoring for the whole Earth, we can begin to see what's happening today. And with the combination of machine learning and advanced AI, we're starting to find the precursors of things that are statistically likely to happen tomorrow. That's a complete revolution in the way we think about creating a more sustainable planet. And it leads me to the very last idea I want to share with you in my closing minutes with you this afternoon. We live in this era of abundant big data. Many of the people in this room, in one way or another, your whole lives are touched by big data, whether you're a consumer or whether you're involved in analytics. And I can say for sure that the impact on it, on all of us, is going to only go up in the years to come. But one of the things we believe is that the era of big data is largely going to be transitory. And the way we think about solving these big problems is with a mental model that I want to show you right now. We think that we're going to move out of a world of big data and into a coming world of big indicators. Indicators tell us how a system is operating. Think about the NASDAQ is a perfect example. Nobody in this room knows, I would think, who's likely to know how the NASDAQ is calculated moment to moment, but we trust it because we know it's based on all this available information, and it allows us to invest in the stock market and understand the health of the economy, all kinds of other things. We're going to apply very similar thinking to solving planetary scale challenges. So down here, this is what we call the 4 eyes model, and I will tell you it's not very imaginative. All the layers start with the letter I. Okay, so the bottom layer is the information layer. So that's what Planet and lots of other remote sensing, open data, and the Internet of Things, all of these structures that are producing these huge volumes of data. We produce 90% of all the available data has been produced in the last 2 years alone. That's largely because we've become very, very efficient at producing it. Now, the problem is that when you have all that information, its volume is very high, and its relative value per unit is actually quite low because there's so much of it to look through. But there's a second revolution that's underway, an insights revolution, and this is happening with machine learning, AI, computer vision, and other statistical models that allow us to correlate across data sets and to pull insights out of that volume of data. When those insights are sufficiently robust that they persist over time, they can become the fuel for new kinds of indicators that tell us about how the world's forests are doing or how the world's water is doing at any scale, right down to the municipal level. And when you have a reliable indicator, you have the structure for building a new kind of instrument. And here we mean new kinds of financial instruments, policy instruments, technical instruments, behavioral instruments that can drive change at scale. Now down there's a lot of data at the bottom, lots more information at the bottom, but a lot of value at the top. And all of us together, and Planet's just a part of this, are taking us up the chain. And with that, I will say thanks. But before I do, I just want to say because we don't have a lot of time for questions, I'm going to stand over there in a few minutes, and if anybody's interested, any questions about Planet, I'll be happy to answer them. That's my email address. I really do answer my emails. Thanks a lot. Have a great day.